Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 18 in the SQL Injection module titled Visible Error-Based SQL Injection. Alright, before we continue with the video, I'd like to announce that this video is part of a course that I offer on my academy. Now you might be wondering, why would I buy a course that is made available for free on YouTube? Well, there are 4 reasons why you might want to do that. Number 1 is that you gain early access to recorded material. As soon as I record new videos, I make them available through my course right away, whereas on YouTube, they'll only be released on a weekly schedule. Reason number 2 is that you gain access to a Discord channel where you can ask questions. The Discord channel is divided into topics that we cover in the course, and if you run into any issues, you get to ask questions about anything related to the course material. Reason number 3 is that you no longer have to deal with YouTube ads or sponsor messages. And last but not least, reason number 4 is you get to support me. Any revenue generated from this course will go back into maintaining the academy and creating more videos and courses that will be made available for free on my YouTube channel. So if you're interested in buying the course, make sure to check out the link in the description. And that is it. Let's go back to our video. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsfigure.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, select all labs, do a search on Visible Error-Based SQL Injection, and select the lab. Alright, let's get started. This lab contains a SQL injection vulnerability. The application uses a tracking cookie for analytics and performs a SQL query containing the value of the submitted cookie. The results of the SQL query are not returned. The database contains a different table called users with columns called username and password. To solve the lab, find a way to leak the password for the administrator user, then log into their account. Alright, so the end goal over here is to exploit the SQL injection vulnerability in the tracking cookie for analytics, and then retrieve the admin user's credentials from the users table and log into their account. Alright, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. Alright, the first thing that I'm going to do is just play around with the application to identify any parameters that could potentially be talking to the backend. So let's click on View Details right over here. It performs this request over here. If we look at the request itself, you could see over here there's a product ID which is equal to 1. That's probably interacting with the backend, so this definitely should be tested for SQL injection vulnerabilities. And if we go down over here, it's a GET request, and so it does not have any parameters in the body. However, if you look over here, there's a cookie called tracking ID and another cookie called session. Now, the session cookie is likely generated by the framework, and unless there is some backend code that takes it in, it likely won't be vulnerable to SQL injection. However, tracking ID is a custom cookie, so it might be vulnerable to SQL injection. We'll start off with testing this one, and if it doesn't work, we'll move on to testing the product ID parameter. So let's send this to repeater. And in repeater right over here, let's make this a little bit bigger and move it to the side so that we could take notes. Alright, so the first thing that I'm going to do is insert a single quote. Now this single quote is part of the SQL characters, and if the application is interpreting this string over here as SQL code, this should interfere with the SQL query in the backend and generate an error. Now the SQL query over here will likely look something like this, so select tracking ID from tracking ID, let's say table, where tracking ID is equal to the tracking ID. So over here, we've got 2 single quotes, and then it would take in the tracking ID right over here. So let's copy that, put it in here, and this is likely what the query is going to look like in the backend. Now, when we added a single quote over here, what happens is that if it's interpreted as SQL code, this single quote over here that we added will end this single quote over here, so the string is complete. However, over here we end up with a single quote that doesn't have an end single quote, and so it should generate an error. So let's see if it does. Click on send over here, and here we go. We do get a 500 internal server error. Now I wonder if we do get an error from the lab itself or the backend database, sorry. And we do. Okay, perfect. So over here it says unterminated string literal. It's talking about the single quote over here at the end. And perfect, it actually gives us the query in the backend. So let's copy this entire thing over here. This is what we call a verbose error. So it's not only telling us that we're using an invalid query, but it's also telling us the details of the query. So this is the perfect scenario for a pen tester. So let's remove all of this over here. This is the real query. It's really similar to the one that I guessed it would look like. So you've got select star from the tracking table where ID is equal to the ID of the tracking ID. And the reason it said unterminated string literal is again because you've got this single quote over here that is not closed off anywhere. So what we're going to do is actually just add 2 dashes. And this way it says to the SQL database, ignore the rest of the query. So it'll ignore this single quote right over here. So let's copy this entire thing and see if we still get an error. Let's put that in here. Hit send. And here we go. We get a 200 OK message and we no longer have the database error. Now, notice over here that the output of the SQL injection does not appear on the page. And so this is technically called a blind SQL injection. But the good thing is that it does generate a verbose error, and we might be able to get the error message to output the password of the administrator user. Now, one way to do that is to use something called a cast function. So that's spelled this way over here. Now, what this function does is it allows you to convert one data type to another data type. The reason this might work is because when you convert to a data type that, let's say, a specific column or a query is not compatible with, it should throw an error, which again may help us in getting the administrator's password based on the error message that it throws. So what we're going to do first is copy this entire thing over here. And actually, let's pretend that we know this, so we'll just add our payload from now on. All right, so that was our previous payload. Now we're going to use the cast function to try and see if we could generate a different error. So let's say and cast the output of this statement, so just select one. As an integer. And then comment out the rest of the query. So let's copy this and see the error that we get. Now we need to URL encode it, so right click and then go to convert selection, URL, and URL encode key characters, and then hit send. And we get another 500 internal server error. And if we go down right over here, it says error argument of n must be type boolean, not type integer. Okay, so it wants this entire statement over here to output a boolean and not an integer, which it does right now. So to change that up, let's copy this again just so that you have all the steps in the notes document, which I'll include a link to it in the description of the video. So over here, let's say 1 is equal to this entire query right over here. So what it'll do is it'll evaluate this part of the query, which is this right over here, and then it'll perform the AND operator on the output of this query, which is 1 equal to 1, and that should output true. All right, this should remove the error for us, so let's copy this and paste it in here. And again, we need to URL encode it. So right click, convert selection, and then URL encode key characters, and then hit send. And we get a 200 OK. Okay, so this is interesting. We no longer get that error saying that it needs to be a Boolean. Now we just get a 200 OK message saying that this query is completely valid. So let's take this a step further and see if we could get it to output some information from the backend database. So instead of saying select one, what we're going to say is select username, which is the column username, from the users table. Let's copy this entire thing. This should definitely error out because you're saying one is equal to all the usernames in the users table. So let's paste it in here. And again, URL encoded. So right click, convert selection, URL, and URL encode key characters. Hit send. And we get a 500 internal server error message, which we expected. And if we go down over here, the error is a little bit different. It's not something that I expected. So it says over here, unterminated string literal started at position 95. And then you could see this is our query right over here. And then it says cast, and then you've got select username from users as, and the rest is truncated. So this is interesting. Now, the first weird thing is that it said it's unterminated string, although we determined that this query over here is valid, which means that this query over here, in a sense, should be valid. It should give me an error that you can't compare, let's say, an integer with a string or a list of columns. However, it shouldn't give me the error of unterminated string. But the reason it's giving me this error is because it looks like it truncated this entire part over here. Now, my guess is that there is some kind of validation in the backend that only accepts a certain number of characters, and we ran out of characters. So we need to figure out a way to make this query fit within that number of characters. And the first thing to go is the tracking ID cookie because it's not necessary. So if we remove it right over here, all it'll do is it'll check where the ID is empty, and then it'll evaluate our query. So let's copy this, paste it in here, and again, URL encoded. So you could do that with Control U as well. Hit send, and we get a 500 internal server error, but if we go down, it still says unterminated string, and it's because we never removed the tracking ID. So let's remove that, just this string. Hit send, go down, and here we go. So the error changed. Now we're definitely within the number of characters that the application accepts. However, it gives us an error which I expected, and the error is that there's more than one row returned by a subquery used as an expression. So over here, it's saying is one equal to a bunch of usernames in the users table, which does not work. So what we need to do is limit the entry to only one username. So we're comparing one to be equal to the first username in the users table. Let's copy that and paste it in here. Now I'm really hoping that this is not above the limit, because if it's above the limit, we might be a little bit screwed because I don't know how to make this query shorter. So right click, convert selection, URL, and then URL encode key characters, hit send, and we get a 500 internal server error message, which again, I expected, because what you're doing is essentially saying is one equal to a string, and the string would be the first username in the users table. And if you look over here, you could see it says invalid input syntax for type integer administrator. So it leaked the first username in the users table, which is the administrator. Now I'm really happy because that means I could also leak the password of the first user in the database, which is the administrator user. So let's copy this. And all we have to do is say select password from the users table and limit it to 1. And we know that the first entry is for the administrator user based on this query over here. So it should leak the administrator's password. And again, we should URL encode this. So Control U, hit send, go down, and here we go. So this is the administrator's password. Let's copy it put it in here. And if we go over here, click on my account, select administrator, put in the password, hit login. And here we go. We logged in as the administrator user and it says, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability manually. Now, we usually script it in Python. However, as you saw, there was a bit of going back and forth when it came to this specific SQL injection because it is a tough one. So what we did is we first tried a query. We tried to build a valid query. When we built a valid query, we were able then to try to leak information from the backend database. Now, you can do that with automated tools, and again, that's a reason why you should absolutely learn how to do things manually before you use automated tools. So for today's lab, we won't be scripting it in Python. If you liked the video, hit the subscribe and share button so that the video reaches a wider audience. Also, make sure to check out my course if you're interested in seeing more videos like this one. Thank you and see you in the next video.